Okay, so how does it look behind you? Pretty good? Worries, that's good. Okay, so let's start with number one. What is area? What does it mean to find the area of a shape?
Find the outer of the box, like the numbers of the outer box.
What do you mean by that?
Like to find the kind of like the perimeter, but outside of the box.
Well, you use those numbers, but what are you finding?
That's multiply on side.
You are multiplying, so you guys are all saying like kind of the correct things, right?
Finding the length.
You have a length and a width, and you're multiplying, but what is it finding? What are you finding?
Area.
Yes, but what is area?
The area of the inside of it.
Because the amount of space the shape takes up. Amount of space the shape takes up. That's the area. The inside of a shape, basically. The amount of space it takes up. Right? Usually it's length times width for rectangles, parallelograms, squares. What about if it's a triangle?
And you'd have to find the length and the height.
Yeah, so we have the base times the height, and then do what? What's the last step in finding the area? Divide it by 2. So don't forget to divide it by 2 there. All right. Okay, for number 2, we have a flower box. A flower box that is 3 feet by 3 feet by 3 feet. Not 3, 3.5, whatever. And whoever this is, Jane, I think was her name, wants to fill the whole thing with soil. We have to find the volume, the amount of stuff we need to fill the inside of this box. How do we do it, Charlie?
Length times width times height.
Good. Length times width times height, which is
I did 3.5 times 3.
3.5. That is not correct. Because we have to do 3.5 times 3.5 times 3.5. If you do 3.5 times 3, you're going to get a different answer. So you got to multiply it 3 times together. What did you guys get when you did 3.5 times 3.5? Anybody get there? Taylor, what did you get?
175.
No, that's not what I got either. Should we work it out?
Yeah, I want to try to do it in my head.
Okay, so let's do 3.5 times 3.5. Let's start here. What's 5 times 5? 25. Carry over 2. What is 3 times 5? 15 plus 2? 17. Placeholder 0 right here, and then we gotta do 3 times 5 again. 3 times 5 is 15. Carry your 1, and then 3 times 3? 9 plus 1? 10. We add, and we get 1,225?
No. 1,025.
Yeah, we gotta make sure we move our decimals. We have 1, 2, so we gotta move it twice. So 3.5 times 3.5 is 12.25. And then we still need to multiply that by 3.5. So let's do that. What is 5 times 5? 25. Carry your 2. 5 times 2? 10 plus 2? 12. Carry 1. What's 5 times 2?
10.
Plus 1? 11. Carry your 1. And 5 times 1? Plus 1. 6. What do I have to put here? Not decimal. Your placeholder 0. What's 3 times 5? 15. Just sneeze. Sorry. What is 3 times 2? Plus 1? 7. And 3 times 2? 6. And 3 times 1? 3. And then we got to add. I'm writing very sideways right now. What is 5 plus 0? 5. 2 plus 5? 1 plus 7? 6 plus 6? And 1 plus 3? 4. How many times do I need to put my decimal here? Ninth place, we have 1, 2, 3 times. So 1, 2, 3. So our volume is 142,875,000 feet cubed. So she needs, good, that's good though. That means that she needs a lot of feet of soil to fill up this box. So when she goes to buy a bag of soil, if she buys a bag that's 40 cubic feet, is it enough? 40 cubic feet is enough to fill 42 feet?
No.
No, she needs at least 43 cubic feet, right? To be able to fill it. Because it's not going to come in exactly 42.875 cubic feet, right? So she's going to have to get something a little bit bigger than this in a bag of soil. That'll be fun to carry. Okay, number 3. What is a net? So if we look at our 3D shape, a cube, what is a net of a cube?
Area inside it?
Kind of. So we have our shape, right? Not a very good drawing. This is our 3D shape. The net is what you get when you unfold it. So it would be something like that. That's the net when you unfold your 3D shape into different shapes. So unfolded 3D shape. All right. And our last one. And we're not going to do all of this math because it's a lot. We need to find the price per ounce. So that means for all of these, you need to divide the price by the number of ounces. So our first one, you would have done 4.89 divided by 15.6. That's a lot of division right there. Probably took a while. Did anybody get an answer? 3.89. That seems a little bit high. It should be really small. 15.6. Yeah, it should be really small. When you divide, I did it on my phone. You get 0.3134. But this is money. So how do I make that into money? We have to round. Well, it's already at its place. We need to have just 2 numbers behind. So we need to round to our 100th place, which means we need to look at the 3. If it's a 3, will the 1 stay the same or round up? Stay the same. So how many? 31 cents. Yeah, 31 cents. So it's 31 cents per ounce that you buy of Wheaties. So if you want to buy just 1 ounce of Wheaties for whatever reason, it's like this big, it would cost you 31 cents. Fun. Our next one. Take your money. $5.29 divided by the ounces. So $5.29 divided by 14. Anybody get that far? Okay. Anybody get an answer there? I got one on my phone. The answer is 0.3778. And it keeps going and going and going, but we need to make it into money. So look at your hundredths place and round. So it says 7 after. Will this other 7 stay the same or round up? Round up. So that means how much is 1 ounce of Chex corn? Not corn Chex. 38 cents.
I bet you the next one will be like 0.2894.
It's going to be higher. I think it's going to be in the 4.4s. So Chex corn. Why is it Chex corn?
Wait, I don't think it would be though because
Corn Chex. It is because the number's smaller. So we're going to take the money. $4.69 and divide it by 14. 4.69 divided by 14 is 0.335. So not as high as I thought it was going to be. But we need to round it again. So you need to round to the hundredths place. Looking at the 5.
yes, we'll go up.
Good. This will round up because if it's 5 or higher, it rounds the number up. So how many cents is 1 ounce of Cheerios?
34 cents.
34 cents. That one, if you were working on all of the division, it would have taken a little bit of time, and we don't have the time to do all that division right now. But that's our warm-up. We're going to kind of work on something that you probably haven't talked about before in math, maybe in science, potentially. So we're going to go ahead and head over to our notes, which I think posted a minute ago.
Are we gonna do multiply? Or see which one? What the distance is between each?
We're not doing any multiplication. Today we're doing a lot of thinking. Okay, so go ahead and head over to Google Classroom. So let's see. If we scroll down to math, we have independent and dependent variable notes. This goes along with the equations that we have done before with x's and y's and all of that stuff. So we're going to start talking more about algebra. This is the last thing that we learned. We're going to learn this for the next 2 weeks. So this is the last new thing that we learn all year in math. After this, it'll just be review and getting you guys ready for junior high, basically. So this is the last new thing, and it is something that you're going to see a lot in junior high. So
Wait, is the AZ merit next week?
the in-person students will take the writing AZ merit next Tuesday. Yep.
I thought you took the writing one. Wait, or is that they just do one every 4 years? Which one is the one you take every 4 years?
Science, I think.
How much more school do you have?
8 weeks? 7 weeks? May 28th first, or May 20th is our last day of school.
That's my brother's birthday.
Yeah.
So why would you do
It's always in April. Yeah. And it's a little bit earlier this year because of coronavirus. They gave us a longer amount of time to get everybody tested for AZ merit. So we're starting a little bit earlier so that we have enough time in case people miss it. So let's open up our notes. So it's the first one, Jones, independent and dependent variable notes. Should look like this. Yeah, there's 2 of them on there. The first one should be the one that says notes. The other one says guided practice, which we will do together. It's just practice together. So start with the notes. I'm going to present it. You guys can follow along on my screen if you'd like to. There are a couple. Actually, let's do the warm-up first. There is a warm-up just to kind of review some stuff. We have done this before. I think that you guys can probably do these 5 questions on your own. So I actually want you to try. Let's take maybe 4 or 5 minutes. You don't have to, what am I trying to say? Try them on your own for a few minutes. And then we will review them together. So I'm going to present it right now just for a few minutes. Let you guys try these on your own. I know that we just did a warm-up, but I want you to do this warm-up too.
That's not that hard.
Not really. So try this warm-up now. I'm going to erase this stuff behind me so I can write on the board. Because this is stuff that we are going to be using for the next 2 weeks or so. So let's practice it. So on numbers 1 through 4, solve for x or y, whichever one it is. So solve for the variable. Take a couple minutes, try these ones.
I need your help on this one. I know that's fine. So that one and that.
So something plus something equals the total amount they have. And figure out what n is, so that's how much y will have, right?
What about 5?
Right.
You said 1 to 4.
Well, 1 to 4 you're solving for the variables, number 5 you're trying to figure out the what's the opposite of adding 17? Yeah. About 1 more minute. You know, I moved the whiteboard. Nothing. So. Okay, I'm gonna fix this up so that we can see it on the whiteboard behind me when we go over it. How does that look behind me? Looks good. Can you see it all?
Yeah.
Okay. So for this one, let's go ahead and look at them. So on the number 1, we're solving for x. We need to figure out what x equals. Remember we do like the upside down t so that we split our equals or our equation in half. And then we have a plus 17. What's the opposite of adding 17?
Subtracting.
So we need to subtract 17 on one side?
The other side.
Both sides. Subtract 17 on both. This positive 17 minus 17 cancel out, and we're left with x equals, what's 23 minus 17? 6. There's your answer. And if you plug it back in, does 6 plus 17 equal 23?
Yeah.
There you go. There's our answer.
You can pretty much just add them together.
You can also, yeah. Some of these you can just look at and be like, okay, the answer is 6. But the farther you go in math, the harder it's going to get. So knowing this process is good as your basics because it gets harder, right? Number 2, 8 plus y equals 39. We have to solve for y. So we split it in half. Is this a positive or negative 8? Positive. So how do we get rid of it? What do we do? Subtract 8 on both sides. 8 minus 8 is 0. Goes away. We're left with y equals 31. Good. Again, you could probably look at that one. 8 plus y equals 39. But
You can look at all of them that way.
you kind of can, yeah. Number 3 is a little bit harder. It's a little bit longer, but that's all right. Number 3, solving for x again. Remember, when you see 3 and an x pushed together, they're being multiplied. Remember we talked about how they're being married, they're being forced together. In order to separate them, we have to divide or get them divorced. 3 divided by 3 goes away, and you're left with x. What did I forget to do on this side?
Divide by 3.
Divide by 3. 48 divided by 3. Does 3 go into 4?
Yeah.
1 time. Subtracting it 1. Drop down your 8. Does 3 go into 18? 6 times. So your answer is 16 on that one.
Wait, 1x equals 16 too?
Yes, you can also say 1x equals 16 or just x equals 16. Because there's 1x, right? You can just get rid of the 1, you don't need it. And then the last one, we have y divided by 5 equals 12. So we have to get rid of this dividing by 5. What's the opposite? Multiply by 5.
Fives cancel each other out.
The 5's cancel and you're left with y. What do I need to do here?
Multiply by 5 is 60.
Multiply by 5. And 12 times 5 is? 60. Y equals 60. How'd you guys do on those? That's one that we haven't done in a while, so bringing it back a little bit, right? Number 5 said something about Lyle. Let me look. Together, Lyle and Adam have $22.75. Adam has $12.20. 20 cents. Wait. How much money does Lyle have?
He has.
So we know that we need to take the amount of money that Lyle has plus the amount of money that Adam has, and it equals $22.75 total. Do we know how much Lyle has?
No.
Wait, let me finish. Do we know how much Lyle has? No, so we're going to leave that as a variable. You can put X, Y,
I put M for
M for money. Whatever letter you want to use is okay. Plus, do we know how much money Adam has?
Yeah.
How much?
$12.
$12, just 12, $12.20. And that plus that equals $22.75. We need to figure out how much money Lyle has. How do I do that?
You have to, so you're going to do the same as
Good. Yeah, we have to solve our equation. So we are going to split it in half. The opposite of adding 1220, subtracting 1220. You have L equals, subtract 1220 over here. 1055. So we have 5. Good. So Lyle has $10.55. And Adam has $12.20. Together they have $12.75. So we will use that concept a little bit later this week, not right now exactly today, but we are going to do practices like that all week. Let me get rid of presenting these things. All right, let's go ahead and head back over to our warm-up and our slides and go over some fun things. Yay. Okay, so let me get reset up right here. I wasn't planning on standing up. Okay, on our notes, if we're presenting it, we did our warm-up. Our next slide talks about independent and dependent variables. We haven't been talking about x's and y's very much, but we have a lot of x's and y's in our equations that we've been talking about, right? So we can think about an ordered pair, an xy pair. Let me write this out. One of them is independent and the other is dependent. Oy, so much racing. Okay, so we have in an ordered pair x and y. It always goes the x value first and the y value second. The x is the independent value. It means that you don't need anything. You can put in your own x for whatever you want. And the y is the dependent. So your dependent value always depends on whatever you put in for x. Because usually you're going to have an equation like y equals x plus 4. We can't solve this just yet because we don't have enough information. But you could plug in your own x. And that's what we're going to start doing. We're going to take, let's say we want x to be 1. We could plug that in and say 1 plus 4 equals 5. So your x value is 1 and your y value is 5. So we're going to do that a lot. But your x is your independent value. It's the one that doesn't need anything. You can make it up. You can plug in whatever you want. And your y value depends on it. So it's called the dependent variable. It depends on the independent variable, which will make more sense the more we do it, I promise. So our first example, we're going to identify what the independent and dependent variable are. When you look at questions like this, ask yourself, what depends on the other one? What has to happen for the other one to happen? So the middle school band gets $12 for every car that they wash at a car wash. So the money here depends on how many cars, right? If they get 0 cars, how much money are they going to make? $0. If they get 1 car, how much money can they make? $12. If they get 2 cars, how much money will they make? 24. So their dependent variable is cars. They said this so weird. The amount of money the band earns in the car wash depends on how many cars. So the number of cars is the dependent variable. Okay. No, it's not. Hang on. Sorry. I was like, that doesn't sound right. The way that they worded that is awful. The independent variable is the number of cars because we can't control how many cars come to get washed, right? So the independent variable is the number of cars, and the amount of money that we make at this car wash depends on the cars that show up. So independent, cars, dependent, money. Does that make a little bit of sense? The money depends on the number of cars. Okay, let's try another one. This time, hey, that's my dad's name. Tim runs 10 miles per hour. Yeah, there we go. Tim runs 10 miles per hour. So the amount of miles that he runs is going to depend on how many hours he runs. So if he runs for 0 hours, he runs how many miles? 0. If he runs for 1 mile, or sorry, 1 hour, how many miles does he run? 30. And it just kind of continues from there, right? So the number of miles that Tim runs is going to depend on how long he decides he wants to run. Because, you know, there's those crazy people out there that there are people that do it. So the independent variable is the number of hours. He gets to decide how much he wants to run, how long he wants to go. He can go for a half hour, an hour, 45 minutes. So he decides. That's the independent variable. And then how far he runs, the number of miles, depends on it. So the dependent variable is the number of miles that he runs. Are you seeing this works? One thing always depends on the other. One thing always has the other. Let's try example 3 on practice. So basically, we're going to have to see together, and then we have some guided practice where we'll do more and more together. Everybody needs to be on slide number 6. We are going to be typing on slide number 6. I know my thing says it's reconnecting. I think we lost some internet connection. Is it back? Okay. I wonder how that works with the recording. Oh well. Okay. Online, are we good? Can you see me? Can you hear me if you're online? I'm going to take that as a yes. All right. Let's go ahead and continue what we were doing. Hopefully we didn't miss too much there. So let me represent my screen. Okay, so we are going to be on slide number 6. That's where I need everybody to be. We're going to type in this one, and we're going to tell and identify what the independent and the dependent variables are. So which one depends on the other one. So if we click in here, there's a text box there already. So Lily sells cookies for $2.50 to earn money. So what depends on the other one? Someone tell me what depends on what. Does the cookies depend on the money, or does the money depend on the cookies?
The money depends on.
The money depends on the cookies. So she has to sell cookies to make money. So our independent variable, wow, that is so tiny. So our independent variable is what? The number of cookies that she sells, or the amount of money she makes?
The number of cookies.
It's the number of cookies. I'll make this bigger in a second. So the number of cookies that she sells is the independent variable. And what is dependent on that? How much money she makes. Okay, and I'm gonna make that much bigger because it's super small. Yeah, I put IND for independent and then DEP for dependent. Let me zoom in a little bit too. I'm really zoomed out. Hang on. Let's do. I'm at 100 just to make it big enough for you guys to see. So the independent variable, the number of cookies that she sells, that really, she can't predict that, right? She could sell 0 cookies at the bake sale, or she could sell 150. But she can't really tell you for sure how much she's going to sell. So the independent variable is the number of cookies. It could be any number of cookies that she sells. But the amount of money that she makes depends on the cookies. So the dependent variable is the money part of things. Okay, about 30 more seconds, and then we will look at number 2. Okay. I feel like the name Gus isn't very common.
No.
No. All right, I'm going to scroll down a little bit to look at number 2. Number 2 says Gus has a pay-as-you-go phone. Have you guys ever had a ever heard of a pay-as-you-go phone? No, payphone is like the ones that you walk up to and you put like 50 cents in to make a call. Pay-as-you-go means that you have a cell phone and you make the calls, and the amount of time that you use it is what you pay for. So it's not like how nowadays where you have unlimited everything and you just pay a certain amount of money for unlimited data. That was back in the day. Like, I talked on the phone for 5 minutes. I owe 10 cents for every minute that I talked, right? So, no, it's less than that.
50 cents?
Yeah. 50 cents for 5 minutes on the phone. So does the amount of money that you pay depend on how long you talk, or does how long you talk depend on how much money you spend?
The way you just said it.
The money, the amount that you talk depends on the money?
Yeah.
Does it?
The money depends on the talking.
The money depends on the talking, because if I talk for 1 minute, it's 10 cents. If I talk for 60 minutes, it's $6, right? So our independent variable here is number of minutes you talk. Or Gus talks. We'll use Gus. So the number of minutes that Gus talks is really dependent on how much he decides he wants to talk. He can talk for 5 minutes on the phone to someone, or he can talk for an hour. It's up to him. It changes. It's never going to stay the same. But the amount of money that you spend, or you owe, I guess, like a bill, right, is dependent on how much you talk. So money Gus owes. So the money Gus owes depends on how much he talks.
Is it one of those phones?
It's probably like a cell phone. The company just keeps track of your data to see how much you use it, and then at the end of the month.
My phone would do
you have to pay them. It's just like how you pay for electricity and heat and gas and all of that stuff. The amount that you use it is how much you owe. That's a payphone, not pay as you go. A payphone is different. That's just like you pay 50 cents, you get a minute. This is, he has a cell phone. He can talk on it as much as he wants. He's just going to owe money the more he talks. Okay?
What would you have to put, where would you pay the money at though?
I don't know. It's probably a bill they send to you. So let's look at slide number 7, our last one, closure. Let me zoom out a tiny bit. That's good. Okay, so it says write a statement about how the dependent variable depends on, or sorry, the independent variable depends on the dependent variable, and then identify the independent and dependent variable. So our first one here says, we need to write a statement. I'm going to help you guys write this one. Does the dependent variable depend on the independent one?
Yes. Oh, wait, no.
Or does the independent variable depend on the dependent?
Independent variable. Is it right?
Backwards. The dependent variables, I'll make it bigger in a second. The dependent variable depends on the independent variable. Because you can change the independent variable however much you want. And that means that your dependent one will change.
Is it for that one?
We also need to do the pizza house one down below. Is this big enough? Can I leave it this, or do I need to make it a little bit bigger? Make it bigger too. There we go. And I'll move it down a little bit. Okay, so the dependent variable will always depend on the independent one, because you can change the independent variable however much you want it. You can change it to -5, 22, 1.5, whatever number you want to put in, whatever equation they give you, you can change it. And whatever the equation spits out is the dependent variable. So now if we're looking at this Pizza House one, Pizza House charges $15 for a cheese pizza plus the number, or plus $1 per topping. So it's always $15, and then the amount of toppings that you put on makes you pay more money. So we have two things here, the independent variable and the dependent one, right? Does the number of toppings depend on the money you spend, or does your money depend on the number of toppings? The money depends on the toppings, right? So your independent variable is the number of toppings you want. Your dependent variable is the cost of your pizza. Because if I just want a cheese pizza, it's $15. If I want a pepperoni, ham, and cheese pizza, that's 2 toppings. Now it's $17. So the cost changes when you put more toppings on it. Remember when I said we weren't going to do a lot of math today, just a lot of thinking? This is what I meant. It's a lot of like, does it go this way or this way? Which way works? Yeah. And then don't turn this in yet because we need to do the guided practice. We're going to do a couple, maybe like 1 or 2. Actually, maybe we'll be done for today, and we'll start with the guided practice tomorrow. Do a few together and let you guys work on an assignment tomorrow. Let's do that. So don't turn this in just yet, because there is a second part of the assignment that we're going to start with tomorrow, and then we will have you guys do some independent stuff tomorrow after that. Make sense?
Yep.
Okay, so don't turn it in. Those of you that are online, that is math class today, so you guys can log out, and we will see you at 12:30 for science. Those of you in class, we're going to head to lunch in about 10 minutes or so.